All right, correcting page 55 in your homework book. I wrote two answers, as you can see. I wrote the one if you simplified, and I wrote the one if you did not simplify. And really on some of those, you could have ended up with something in between also. So if you got something different and if you want me to check to see if it's correct, you can either shout it out or put it in the chat for me.
I forgot my math books at home, but I'll do it when I get home.
Okay. How are we doing? Any questions on this page?
Dad. I'm going past the school right now.
Awesome.
Oh, yours. Hold on.
I'm going past the school right now.
Awesome.
Where is she?
All right, guys, are you ready for me to go to the other side? Here we go. Yours for number 11 might be different because we were just writing a word problem.
What page is that?
It is page 56, I believe.
Page. Home. Work.
All right, how are we looking on these? Any questions?
Can you stay on a little longer?
I can.
Miss Triplet,
Yes.
my internet is like terrible. You froze there for a second, and I'm not able to get into Otis or my email, and it took me a long time to get into PE.
Okay. Thank you for letting me know. Just do the best you can today, okay?
Okay.
All right, guys, are we good with this page?
Yep.
All right, and if you're not, I do have these answers posted in Otis, and you can always go back to this amazing video and correct during the video too.
Jeez.
So we are in our student activity book, page 81, lesson 3-6. We have been doing lots of multiplying with fractions, just fractions. Well, now we're going to move from just multiplying fractions to multiplying mixed numbers. What is a mixed number? Can somebody please remind me?
A number that's bigger on the top than the bottom.
No, that's a fraction greater than 1.
A number that's like 1 3/4 or something like that.
Yes, it has a whole number and a fraction, a whole number and a fraction. That's a mixed number. So right here we have 1 2/3. That's a mixed number, okay? Avery, I'm glad that you brought up fractions greater than 1 though, because we are gonna need to remember how to go from our mixed number to a fraction greater than 1 in order to do this multiplication. But like we always like to do in Common Core, let's take a look at how this looks with pictures first, okay? Let's look at our pictures first. Do I have a volunteer who can read? We're gonna read these first 3 little parts here.
A farmer has a rectangular field 1 2/3 mile long and 3/4 mile wide. What is the area of the field? Melinda knows the area is 1 2/3 times 3/4. She explains how she makes an area model to find this product. I need to make a rectangle with sides with side lengths 1 2/3 units and 3/4 unit. I start with 2 unit squares because one side of my rectangle will have a length greater than 1 unit.
Excellent, good. So yeah, so you know how when we were doing this before, it was just 1 square? Well, now we've got 2 squares and they're kind of stacked on top of each other here. So here's 1 square and then underneath it is the other square. And the reason, anybody know the reason why we need to have 2 squares instead of just 1 square?
Because there's 2 fractions?
No, because we were okay when we had 2 fractions because we do 1 on one side and 1 on the other side.
Because one of this. Oh wait, never mind. That's the no. Okay, never mind. I forgot what I was gonna say. So.
That's okay. If I was trying to diagram 1 2/3, could I do that if I only had 1 square?
No.
No, I can't because 1 is that whole top square. 1 takes up 1 whole square. So in order to get to the 2/3, I need my second square. 1 2/3 is greater than 1. So I need more than 1 square. Okay? So let's look at their steps that she said she did. She said first she shaded 3/4 vertically in red. So you can see where she divided it into 4 sections and then she shaded in 3 of those and she goes all the way from the top to the bottom. Okay. And then horizontally, I shade 1 square and 2/3 of the other because it's 1 2/3. So this whole square is the 1. So we shaded in that whole square because that was 1 whole. But my bottom square, I had to divide into thirds because I only need 2/3 of that. So then I'm going to shade in 1, 2. Okay. So the overlap of has an area of 1 2/3 times 3/4. But we still can't really tell what that is because this whole top square isn't divided both ways. So she realized that, and Melinda says, okay, I have to divide the top square into thirds also. So she went back and she divided this one into thirds. Let me separate out those 2 squares again, just so you can kind of see. There's 1 square and the other one's on the bottom. Okay, so she had to divide this one into thirds also. But how many thirds are in 1 whole?
3.
3/3. So she shaded in all 3 of those thirds. And then this one she also divided and she only shaded in 2 of those thirds. So that would be 5/3, right? 1, 2, 3, 4, 5. She shaded in 5/3. Tell me something, friends. If I have 1 2/3 and I want to change that to a fraction greater than 1, hopefully you remember how to do that. I'm going to talk you through it. You multiply the denominator times the whole number. So what's 3 times 1?
3.
3.
You add the numerator to that. What's 3 plus 2?
5.
5. And you keep your old denominator, 5/3. So we just changed our 1 2/3 to 5/3. We changed our mixed number to a fraction greater than 1. Okay. So now she can tell that there are 15/12 in the overlap, because this section right here is the overlap. And there's 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 of those shaded in. And here's where the 12th comes from, because this can be kind of tricky. You don't look at the total number of squares in the whole. You look at the total number of squares in just one of those squares. Okay, so that's where we get the 15/12, because if I just look at my orange area here, if I just look at my orange square, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can see that that's divided into 12 sections. So that gives me 15/12, okay, which is 1 1/4. The area that's shaded is 1 1/4. Let's look at 15/12 one more time. 15/12, if I want to change that back to a mixed number, I divide, right? We're remembering back to the first few weeks of school here. I have to divide 12 into 15. Well, I know 12 goes into 15 one time. 1 times 12 is 12. Subtract, I have 3 left over. My remainder is my numerator, and I keep my old denominator. So I get 1 3/12, which is the same as 1 1/4. Okay? Whew, that's a lot. Let's keep practicing though, because I know that that's a lot to get from just one sample. Of course, this next one, they're going to get a little fancier on us even, and they've got 2 mixed numbers. Can I have a volunteer read me this part right here?
When I rewrite the factor 1 2/3 as a fraction, I can see that the product is the product of the numerators over the product of the denominators.
Awesome. So they started with, and this is still talking about the top one, 1 2/3 times 3/4. If you have a mixed number, you cannot multiply it when it's a mixed number. You have to change your mixed number to a fraction greater than 1. Okay, but then if I have 5/3, I can do 5/3 times 3/4, because they're both fractions. And it goes back to the same way we were multiplying last week. Multiply my numerators, 5 times 3 is 15. Multiply my denominators, 3 times 4 is 12. And I get 5/4. Well, I get 15/12, which I can simplify to 5/4 to 1 1/4. Okay, and those of you who really, really liked that cross-canceling lesson we did on Friday, look, I could cross-cancel these 3's, couldn't I? And change them both to 1. And then when I multiplied the first time, I would get 5/4 instead of 15/12. But the most important part, if you guys are daydreaming and playing Fortnite or Among Us or whatever it is and not listening to anything else that I'm saying right now, the one thing that you have to know is that you cannot multiply a mixed number. It has to be changed to a fraction greater than 1 in order to multiply it. You cannot multiply if it is a mixed number. It has to be a fraction greater than 1. Okay? So let's look at this next one with the 2 mixed numbers. We're looking at the model here, 1 2/5 times 1 1/2. Okay, so this one, holy schmoly, I'm going to use my highlighter again because they have 4 squares going on here. They've got a line right there between squares and a line right there between squares. Do you see those 4?
Yes.
So there are the 4 squares that they are using for this model. So what unit fraction does each of the, well here, let's look at this first. Let's talk about it. So 1 2/5. So I've colored in my 1 whole and then 2/5 more going this way. 1 1/2. I colored in 1 right here, and then half of the next one, okay? Or 3/2 and 7/5. Now, if I wanted to look at a unit fraction, how many pieces are in one of the squares?
10.
10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So what unit fraction? My unit fraction would be 1/10. How many unit fractions are in the overlap? So now we're looking at this piece right here that are both red and blue. How many are in the overlap?
21.
21.
21, you've got it. There are 21. Express the product of 1 2/5 times 1 1/2 as a fraction and as a mixed number. So if I have 21 1/10 pieces, what is my fraction?
21 over 10?
21 over 10. 21 over 10. And now they want me to also rewrite that as a mixed number. So let's see. I need to say, okay, 10 goes into 21 2 times. 2 times 10 is 20. Subtract, I have 1 left. So that would be 2 1/10. And then the last step is the way that you're more than likely going to be solving all of these. Rewrite 1 2/5 times 1 1/2 as a product of fractions. So this is where I need to change each one of these to their fraction greater than 1. Okay? So again, if you forgot how to do it, let's talk about this as we go. We multiply our denominator times the whole number. So 5 times 1 is? 5.
5.
And add the numerator.
7.
7.
So that would be 7/5 because we keep the old denominator.
The other one is
Times 2 times 1 is?
2.
2 plus 1?
3.
3. So that's 3 over 2 because we keep our old denominator. Now if I was going to solve this, 7 times 3 is?
21.
21. 5 times 2 is?
10.
10, yes.
Well, that's the same.
Did we get the same answer?
Yeah.
Yes.
Yes, we did. All right, let's turn the page, friends. All right, some practice with these. Can I multiply 5 6 times 1 1/3 the way it's written there? No, why not?
Because 1 is a mixed number and you have to have them both as a fraction greater than 1.
They have to both be fractions. Awesome. Thank you, Jackson. So my 5 6 can stay 5 6. But 1 1/3 I need to change to a mixed number. So 3 times 1 is?
3.
Plus
3.
1?
4.
4. 4 over 3. What's my answer going to be?
20 over 18.
20 over 18.
20 over 18. Let's simplify that. Let's change that to a mixed, to a mixed number. 1 2/18 I hear. Yep, 18 goes into 20 one time with 2 left over. Do you guys notice that all of our answers have been greater than 1?
Yeah, because when you multiply greater than 1, it's going to be greater than 1.
Yeah, we're multiplying them by mixed numbers. So we're ending up with answers that are mixed numbers a lot of time. Does it always have to be that way?
Yes.
No, it could still become smaller. It could still become smaller depending on what your fraction is, because that other fraction is still less than 1. Let's look at number 6. I think number 6 is trying to trick us. Oh, is my iPad going to sleep? Wake up. There we go. So 3 2/3, let's change that to a fraction greater than 1. So 3 times 3 is?
9.
Plus
9.
2,
11.
11.
11 over 3 times, how am I going to write that 7?
7 over 1. 7.
7 over 1. Ooh, somebody, I heard a 7/7 in there. Let's talk about that for a minute. If I had 7/7, would that equal 7 if I simplified it?
It will equal 1 whole.
It would equal 1 whole, and 1 is different from 7. But if I have 7 over 1, right, that's a fraction greater than 1. Let's check this out. If I wanted to change that, I would do 1 goes into 7, 7 times, subtract, I have nothing left over. So that is the same. So when you have your whole number, you just have to put it over 1. All right, 7 times 11 is?
77.
77.
77.
Times 1?
3.
3. And then, oh my goodness, this is some, let's see, 3 goes into 77. Well, 3 goes into 7 2 times. 6, subtract, I have 1 left over. Bring down my 7. 3 goes into 17 5 times. That's 15. Subtract, I have 2 left over. So I got 25 2/3. Whew,
That's a big number.
that is a big number. All right, how are we feeling about this? Give me a 1 to 5 in the chat. 1, not making sense at all. 5, I could teach the class.
I just don't understand how to multiply it. But
Okay.
I understand like changing it to the numbers.
Okay. All right. Looking good. All right, let's do a couple more up here, and then we'll hop down to the bottom. If you feel like you've got these up top, you can continue working through number 12, but stop when you get to number 12. Okay? If you're still kind of stuck, then let's do some more of these together. So 1 3/4, I need to change to a fraction. I'm going to do 4 times 1 is 4, plus 3 is 7. So that's 7 over 4. Times 2 1/4. I need to do 4 times 2 is 8, plus 1 is 9. 9/4. Now, the multiplying part is really kind of the easiest part when you think about it, because all we're doing is multiplying our two numerators together. 9 times 7 is
63.
63. And then I'm multiplying my two denominators together. 4 times 4 is
16.
16. Yeah. We're just going to leave it like that. We're not going to change it back to a mixed number. We're going to leave it as a fraction. All right. 4 1/2 times 4/5. 4 times 2 is 8, plus 1 is 9. So I have 9/2 times 4/5.
Your screen is frozen for me.
Is it frozen for everybody?
Yes.
Yeah. Yeah, it's frozen.
I'm frozen?
No, not you.
The iPad's frozen.
Not with
Okay.
me.
So if I write my answer 36/10, can you see that answer?
No. No.
Okay, so let me stop sharing and then share again.
All we can see is
Okay, so let's look at number 9. 7/8, we don't have to do anything to. 1 2/5, 5 times 1 plus 2 is 7 over 5. Multiply my numerators. 7 times 7 is 49. Multiply my denominators. 8 times 5 is 40. And that's it. There's my answer.
I get it now.
Awesome. Let's skip down to the word problems because I really want to make sure we get to the word problems. Okay? Because you're going to have a quick quiz tomorrow, and the quick quiz is going to be all word problems. But all we've been doing is multiplying fractions, right? So you should know to find your numbers and multiply them. So Sarah built a pen for her pet rabbits. The pen measures 2 5/6 yards by 1 1/2 yards. What is the area of the pen? Well, we know area is multiply. So I have 2 and 5, 6 times 1.5 equals P for the pen, because we have to write our equation. Okay. 6 times 2 is 12, plus 5 is 17 over 6, times 2 times 1 is 2, plus 1 is 3 over 2. Ooh, I really want to cross cancel. You guys okay if I cross cancel on this one? Do a little simplifying? Because I see my 3 and my 6. And I know that 3 goes into 3 one time, and 3 goes into 6 2 times. And that's going to make it so I don't have to multiply 17 times 3. 17 times 1 is 17. 2 times 2 is 4. 4 goes into 17 4 times with 1 left over. Yards. Whoops, what am I doing? Yards squared. Okay. At Southtown High School, the number of students in band is 1 3/4 times the number in the orchestra. If 56 students are in the orchestra, how many are in the band? Well, we have to do our orchestra times the number in the band. Okay. Equals S for students. I need to rewrite my problem so I'm able to multiply it. You cannot just do 56 times 1, guys. You cannot, I can't say it enough times. You cannot do 56 times 1.
Why not?
Because it will not get you to the correct answer. That's not how we multiply fractions. I need to do 56 over 1 times 7/4.
Okay.
That's what my tutor was doing with me.
Awesome. I can cross cancel this one also, and I'm going to do that to make this a little bit easier. I know that 4 goes into 4 one time. 4 goes into 56 14 times. So now I have 14 times 7, which gets me 98 students.
Ooh, my.
It would be 98 over 1, right? Because I've got 1 times 1, so I just held off on multiplying those denominators. And we can go back and check our answers, guys, and make sure they make sense. Would that make sense? If there are 56 students in the orchestra and there's 1 3/4 times that number in the band, you're going to have more in the band, right? Because 1 times 56 equals 6. But I've got this extra 3/4 in the band. So that tells me that my band number has to be bigger than my orchestra number, which it is. I've got 98 students. A bucket holds 2 3/4 gallons of water. The bucket is 5/8 full. How much water is in the bucket? Equals W for water. 4 times 2 is 8, plus 3 is 11 over 4, times 5 over 8. Oh, I can't do any cross canceling on this one. 11 times 5 is 55. 8 times 4 is 32. Got to do some division. 32 goes into 55, right? The bottom end of the top. 1 times, subtract, I have 23 left. So 1 and 23 over 32 gallons. All right, one more. You guys still with me?
Yep.
Yeah.
I have to be.
Jacob's favorite movie is 1 5 6 hours long. Ouch, I have to be? Don't you
I was making a joke.
Okay. Jacob's favorite movie is 1 5 6 hours long. He says he has watched the movie 5.5 times. That's a lot of movie watching. If that is true, how many hours has Jacob spent watching the movie? Equals H for hours.
Oh my.
6 times 1 is 6, plus 5 is 11 over 6. 5 times 2 is 10, plus 1 is 11 over 2. Oh, 11 times 11. Anybody know that multiplication fact?
11 times.
110.
121
Oh, 121.
over 12.
Oh my.
Whew. 12, let's simplify that to find out how many hours. 12 goes into 121. Well, I know 12 goes into 12 one time. Subtract, nothing left. Bring down my 1. I still have to try and put 12 into 1. It can't go in there, so that's my 0.
Oh my.
So I have 1 left over. So 10 and 112 hours he spent watching the same movie.
Oh, my.
Yowzers. Yowzers, yowzers. All right, let's take a minute to take a look at our homework book, guys.
Yay.
Here we go. Very much like the page we just did in our practice book, right? The top half has just straight solving problems, and the bottom is word problems. Please listen, I'm gonna modify what you need to do. I want you to do 1, 3, 5, 7, but I want you to do all of the word problems, 9, 10, 11. So you can just leave out this 2, 4, 6, 8, okay? That's why I couldn't just say do the evens or do the odds, because I want you to do all of the word problems and then it's 1, 3, 5, 7.
1, 3, 5, 7, 9, 10, 11.
Okay, 1, 3, 5, 7, 9, 10, 11, you got it. And then on the back, let's just say evens on the back,
Evens on?
okay? Evens on the back. Actually, I'm gonna change that, so sorry. I'm gonna make it odds because I want you guys to do the stretch your thinking.
Yay.
Odds only on the back. You can, of course, do every single problem on both pages if you want. But these are the ones that you have to do, okay? Because you're also going to do one of the multiplication slides that you have assigned. You guys had one that we did last week, and you need to get one done today. So let's go ahead and fill in our planners. Oh, why did I stop sharing?
Oh, it's Columbus Day.